Right, in the video that we've just looked at, which was a reaction between NO2 and NO2 to make N2O4, and then back the other way, so dynamic equilibrium, it was sort of pretty hard to explain what was happening. So this is our equation here, and what we can see is that for every 2 moles of NO2, they can become 1 mole of N2O4. So the amount of space that N2O4 takes up is half as much as the space that the NO2 takes up in this equilibrium. The two things I did is change the temperature and change the pressure. If we think of it like a seesaw, so I use my little whiteboard marker as a seesaw, the pivot being in the middle here, at dynamic equilibrium, the rate of reaction forward and reverse is the same. That's why it's a dynamic equilibrium. Equilibrium, all the same. Dynamic, there's change, but we're not seeing it. Okay, forward reaction, reverse reaction, same. So my seesaw is balanced. When I increase the pressure, what I end up doing is tipping the seesaw this way. So to get it back into a balance, and the reason that it tips is because with less space, these particles are colliding more often. Okay? So with less space, this equilibrium's it's not an equilibrium anymore, things are changing. So it tips the equilibrium this way here. To get back to an equilibrium, my seesaw needs more things on this side. So it makes more and more N2O4 until it's balanced again. And now the forward and reverse reaction rates are the same. If I decrease the pressure, then these are colliding less often, so they're less likely to become N2O4. But the N2O4 is still just as likely to break down to NO2. So by decreasing the pressure, I tip my seesaw this way. And so it will keep favouring the reverse reaction. This reaction rate will be higher than this one until it gets back to being balanced again. Once it's balanced again, the two reaction rates are the same. But it does mean that the concentrations of these have changed from my original equilibrium. Same thing with when I added heat energy or cooled it down. The forward reaction is exothermic. We found that out from our results. So when I cool it down, it actually tips the equilibrium this way. So to get it back to equilibrium, it has to produce more products. And in doing so, it also heats up the system a little bit because it's the exothermic direction. Okay. Likewise, if I heat it up, it tips the equilibrium this way. There's too many N2O4 molecules for this. So it will keep making NO2 until the forward and reverse reaction rates balance out. So that's, the seesaw analogy is quite a nice way to think of it. The Chatelier principle is basically saying that the seesaw has to be balanced. So if I change something, then which way does it tip the seesaw? How's it going to undo that?